Welcome to Laurier's Teaching Excellence Conversation Series. I'm Deborah Vinayatan, Academic Director of Teaching Excellence and Innovation at Wilfrid Laurier University. And today I'm with Christian Danve Castroverde from Laurier's Biology Department, who received the 2025 Early Career Excellence Award in the full-time category. In only 5 years at Laurier, Danve has earned a reputation for bringing passion, creativity, and care into every class. His teaching approach is rooted in universal design for learning, inquiry-based strategies, and scaffolded instruction, making complex scientific ideas clear, engaging, and inclusive. From his pioneering use of AI tools in assignments to his dedication to student mentorship, Danve equips students with the conceptual knowledge and scientific thinking skills they'll need to thrive as scientists. I'm so excited to talk with him today. Thank you so much for joining me here today, Danve. In your teaching dossier, one of the things that's very striking is that you talk about your teaching time as finite but meaningful. Talk a little bit about that. What does that mean?
Well, thank you very much for that question, Deborah. And absolutely, I do acknowledge that students in my courses, they only spend a limited number of hours in my class, like dedicated to studying for my courses each week. So, for example, it's three 50-minute sessions or two 80-minute sessions. But my hope and ultimate goal in that very short time is to make a lasting impact, not just
Yeah.
on what they know, but hopefully how they think as well. And I think that philosophy really stems from the fact that I want my students to learn the cross-cutting themes and core concepts of biology, but not only that, being able to discern what is accurate information and what is not. And I think this is uh, an important facet of my pedagogy because eventually students will move on. But I think that ability to think critically is hopefully something they will take away
And
from
so
my
that's how you
courses.
organize each class, right? You're
Yes.
starting with, you noted big questions in
Yes.
science that are pose sort of the underlying theme for the class, and then your classroom activities kind of contribute to elucidating that, right? Helping
Yes.
students unpack that.
Yes, that is very accurate. And those big picture questions, like really, I think it's my way of making students see and feel that taste of real science,
Yeah,
that
yeah.
it's not just a set of facts that they have to memorize, that they have to learn, that science is actually that evolving dialogue and conversation, like new facts, new knowledge are discovered, old facts and knowledge can get replaced or revised. And by positioning each lecture with big picture questions like, why is it that plants are resistant to most diseases? So by positioning the specifics of the lecture within the broader context of knowledge, it allows like the students to see the forest for the trees per se, like like how is this relevant to everyday life and moving forward as they continue throughout their academic career.
And it's also you're introducing them to what is a global dialogue on these questions, right?
Yes,
Like it's
yeah.
not just happening in this class. These are questions that we as scientists, that you as scientists, right,
Yes.
are grappling with.
And a lot of
Yeah.
these questions don't have complete answers. I mean, that's why there is still science, because there are still unanswered questions or new questions being asked with each new answer that we are discovering. And my hope is that this next generation of scientists and or research leaders will take away not just that clarity of conceptual understanding, but also a curiosity or a sense of wonder to discover more.
Is that hard to do? I know you have a large second year class, 450 students approximately, right? Is
Yes.
that hard to do in a large lecture class like that?
I mean, definitely it is challenging. I mean,
Mhm.
both in terms of reaching that many students and being able to assess or evaluate whether,
They're taking it
yeah, they're
in,
taking it
processing.
in
Right.
and
Yeah.
processing it. And that's why I try to have different instructional strategies and assessment modes as much as possible,
Yeah.
both formative and summative assessments, just so I can gauge, what is the pulse of my students in
So
class.
take us through one class. You're posing the big question.
Yes.
And then what are you doing with the class in terms of your formative and summative assessments?
So, for example, in my plant molecular biology classes, so that would be third year and fourth year, so smaller classes, after posing the big picture question for that class meeting, I will first have an overview of what the concepts would be, and then each class will have sub questions that will eventually reinforce the big picture
Right,
question. The
right,
same way
right.
that when we're doing research, we have those overarching goals, long-term objectives, and we break it down to short-term objectives that are actionable, measurable, and feasible. And then
Yeah.
this modularity of the lecture, I think it makes it less onerous for students to take in. And then from that organization, I'm modeling the way I'm organizing facts into themes uh, so that this could hopefully guide students in their own organization when they're note taking and trying to understand the concepts for that class meeting.
But in the course of doing that and you sort of leading them through the content, you engage students in so many different ways. Using the pop culture analogies,
Yes.
grouping the themes or grouping the course content thematically, getting students to talk about narratives, so many different. Talk a little bit about that because again, you're teaching really large classes,
Yes.
everything from really large to smaller,
Yes.
but the whole time thinking about how students can be actively engaged in
And I
class.
think engagement is quite important because there's sometimes this misconception that students are just passive vessels receiving information, but
Yeah.
really they are active agents of their own learning. They come with preconceived notions and conceptions, and our goal or our job as teachers, as educators, is really to reinforce the right conceptions and hopefully revise some of the less accurate misconceptions that students have. So
How do you know when they've got something, when they're, bang on, they've got this knowledge or they don't?
So, for example, in my second year cell biology class, so the big courses, even as simple as eye clickers,
Yeah.
I
Yeah.
would do, like within a class lecture, perhaps three, so that there's a mental break. And then, okay, this eye clicker question would hopefully encapsulate what has been discussed for the past 10 to 15 minutes
Yep.
of that particular class meeting. And then it's chunked throughout the whole lecture. When we do iClicker questions, so apart from just looking at the poll numbers, when the statistics are not as good, I ask them, okay, maybe let's do think, pair, share. Like talk to your seatmates.
Neighbor. Yeah.
For the most part, like impressively, students get the correct answer. What I do is then go through each of those choices and then I ask for volunteers, like if that's the correct answer or not, and justifying why one choice is correct, but more importantly, justifying why the rest are not. Because there's so many ways in
Right.
answering
Right.
a question wrong for the most part, but being able to know, okay, where did that answer trip up? Because there's always that, like endless possibilities
Yeah.
in answers. And by doing so, hopefully I can um, impart that critical analytical thinking, like how do we use deductive reasoning and logic to arrive at the
Mm-hmm.
correct answer. And that's what science is.
And so they're doing think, pair, share after that. And then you're talking in class, even if it's a big class. You're saying, hey, why is this
Yes,
answer not
yeah,
right?
yeah.
Yeah,
And then typically
great.
there's would like I would ask for volunteers, and it would be a conversation with the volunteer, and but in a safe and open manner, like without putting anyone on the spot per se.
Yeah, but it's also fun. It's
Yes,
playful, right?
yeah.
Because you're doing polling,
Yeah.
you're,
I also use humor and
yes.
memes, for example. And this one, I try to incorporate it as memes on slides or even just analogies that I would use off the cuff. And I think it is important because, especially teaching sciences, it's a lot of complex terms and technical jargon. So trying to demystify it into relatable concepts and more fun concepts
Talk
make
about the house. I love the analogy of the house.
yes, yeah. So for example, the plant immune signaling pathway, like I would
It's brilliant.
use home security or just someone visiting the house. So for example, in the plant immune system, or how plants defend themselves against pests and pathogens, pests and pathogens can be detected first, like using these pathogenic fingerprints. So that can be analogous to like home video cameras that can monitor who's outside
Right.
of
Who's
your
trying to get
house.
in?
Yes, yeah, exactly. And then like the sensors, for example, plants have their own sensors that can detect these presence and then can activate intracellular or machinery of like signaling machinery inside the cell. So that will be similar to electrical circuitry and gadgets that can have the appropriate response, like whether it's calling 911, for example, or a home security system, or just alerting you to take appropriate action. And that's the same case with plant defenses. It's only upon successful perception of these invading pathogens can plants have appropriate responses. And then on a more lighter note, I have an analogy, and I'm actually scared that it's on borrowed time because it's quite early 2000s reference. So like in cell biology, there are these receptor protein complexes, and they're trimeric. So it's three proteins. They all come together to function, and it's labeled alpha, beta, and gamma. So the subunits of these G protein coupled receptors. But it's really the alpha subunit that kickstarts everything and does a lot of the heavy lifting. So I use Destiny's Child,
Oh,
the musical trio with
yes,
Beyonce
yes.
from the early
Yeah, yeah.
2000s
I
as
love that.
as an analogy that yes, they work as a group, but you know who the alpha is. And of course they know who the alpha is.
But
Yeah,
you're
exactly.
worried that in a few years they're gonna be like, who
Who's
Destiny's
Destiny's Child?
and
So
what does that have to do with Beyonce?
yeah, exactly. So I try
Yeah,
to
I
ask
love it.
them if that is still relevant. But yeah, I
So
think
far, so good.
so far so good. And
Yeah.
I think just peppering this allows me to punctuate the lecture with those like unexpected points. I think by framing a lecture as a narrative, wherein there's exposition and then
Yeah.
maybe mystery or just moments of unexpected surprises or plot twists, like it hopefully it makes it more memorable for students, like instead of a rote routine, just me talking for 50 or 80 minutes.
No, it sounds like it's very fast-paced, right? Especially if
It
you're,
is.
and your dossier makes clear that you always deal with content in chunks,
Yes.
right? And then you do a sum up or a little testing, and then another chunk.
Yes.
And
Yeah.
that, I think, breaking it up that way makes that. I imagine the 50 minutes goes very quickly.
Yes, because really 50-minute lecture is really a 40-minute
Yeah,
class time. Like there's
absolutely.
that 5-minute
Shuffling,
buffer
yes,
in the beginning
yes,
and at
yeah,
the end.
and maybe some shuffling in between polling,
Yes,
and
yeah,
yeah.
exactly. And that's why I emphasize that meaningful and finite. Like I even use that quote from Gandalf from The Lord of the Rings, like to paraphrase,
Yeah,
what is important is what to do with the time
that you
that
have.
that we have, that,
Yeah.
in Middle Earth.
That's like a life philosophy, not
Yes,
just a
yeah.
teaching
Yeah,
philosophy. Yeah.
exactly. Like a
Yeah.
life philosophy. And I try to apply it with my teaching because really it's like we eventually retire as educators, but knowledge doesn't. But how do we propagate knowledge? It's really harnessing the power of information, because information is always out there, but it's about the thinking and being able to generate new knowledge, that what sets us apart as humans from the emergence of AI, for example.
We'll talk about that in a minute, but I
Yes.
love that quote. We will eventually retire, but knowledge doesn't.
Yes.
Okay, that needs to be written down somewhere. Let's talk a little bit about generative AI in teaching, because you've been an earlier explorer here, right? I mean, it burst onto the scene in November 2023, and we've been sort of running to, I think, in a sense, catch up and understand what it means for our teaching, how we adapt our teaching, how we maybe look for opportunities for our teaching. So you're actually having students engage with Gen AI tools and also critique them. Can you discuss a little bit what you're doing in your class with that?
Well, thank you for asking that. And that's an excellent question. So, really, when artificial intelligence burst into the scene for mainstream use, I mean, of course, as a scientist, there's that
Yes.
level of
Yeah.
skepticism and
Right.
anxiety. I mean, it is quite a technological upheaval.
Transformation.
It is very transformative,
Yeah.
disruptive technology. I mean, we're probably going through another industrial revolution per se.
Yeah. Yeah.
But
Yep.
I mean, I thought to myself, the Pandora's box has been opened. It is here to stay. So I think it is important to hopefully get ahead of the curve, or at least be within
Treading
the
water.
curve. Yeah, exactly.
Yeah.
I mean, we've seen countless examples in history of either individuals or companies that did not adapt or evolve with emerging technologies, and it has not always gone for the better with them. And since the technology is there, it will be used by workplaces, like once students move on from
And it's being
university.
used by students. The research is very
Yes,
clear.
yeah,
Right.
exactly. So I wanted them to critically engage with it. So use AI and harness its capabilities as a partner, a collaborative partner, rather than a crutch, and being able to discern what is accurate and what is not. I mean, we know how AI hallucinates information within the context
Right.
of
Right.
your prompt. So in one of my classes, so I experimented with this in that third year plant molecular biology. Um, the main semester long project, each student is assigned a plant gene of interest, so a unique one, and that's their baby for the semester.
Yeah.
And at the beginning of the semester, they use ChatGPT to perhaps describe how this gene is regulated, what is the function of these gene. I try to standardize the prompt,
Yeah.
like what,
Right. Right.
like what's
Right.
what the tone is, what like how many words, and then they just replace the gene name for what they've been assigned. And throughout the semester, their work is to comprehensively read and survey the literature by reading peer-reviewed journal articles about their assigned planned gene of interest. And at the end of the semester, they would then submit a critique of the ChatGPT text, critiquing it paragraph by paragraph or sentence by sentence with peer-reviewed citations. So for example, if ChatGPT says gene X is involved in process Y, then students must justify it well in
Is
a,
it actually, is
yeah,
that
is
the
it actually
case?
the case? So for
Right.
example, they would say, well, in Smith et al. Or Wang et al. 2020 paper, they showed that mutants for this gene has perturbed process X, therefore implicating it in that
So
process.
are they annotating the original
Yeah, yes.
output from? Oh,
Yes,
yeah.
yeah,
That's
exactly.
great.
That's my way of hopefully allowing students not just to engage, but critically engage with AI, but also seeing where its strengths and limitations are.
Absolutely. But also how they can acquire knowledge to critique
Yes,
AI
yeah,
outputs,
exactly.
right? So,
But of course, like I do acknowledge, like gaining that ability, it just doesn't come out of thin air. I mean, as a student, I struggled a lot with original research
yeah,
articles, like
yeah,
trying to get into this new language of reading
yeah.
papers. So throughout the semester, we have journal clubs wherein there are assigned journal article readings so that we can, as a group,
Yeah.
demystify
So that's going
how
along
papers.
alongside this
Yes.
work on the,
Yeah. And
yeah,
then, of course, like these journal clubs, they're articles that reinforce the concepts that are in the lecture. It might contain some of their genes of interest, but not exactly focused on any particular gene, but at least it allows them to see what is the structure. There's always a recipe with peer-reviewed writing. Even looking at
absolutely. Yeah.
an abstract has a mini intro, has a mini rationale or a statement of where the knowledge gaps are or the
Hmm.
controversies, and then a statement
Major
of the major
findings.
findings, like
Yeah.
here we show
Yeah.
dot dot
Yeah.
dot, and then its implications. And by demystifying the structure of the abstract, we call it the anatomy of the abstract, and how that relates to the anatomy of a research paper. It makes reading less onerous, like it's less uh, a solid like brick or concrete wall. Like you could
Yeah.
see each
Here
individual
are the,
brick,
yeah,
each
that's right. That's a
individual
great
piece of the
analogy. Yeah.
puzzle, and
Yeah.
it's more workable and less daunting and overwhelming.
I want to talk a little bit about your interest in universal design for learning, which, again, speaking of intentional, you really try to use those principles to ensure that your classrooms are inclusive spaces. So, how do you create an environment where students feel safe, where they have various opportunities to succeed?
So that's a fantastic question, it and I feel like I do incorporate UDL principles, but UDL principle is not a static goal. It is
Mhm.
ever
Yeah.
evolving. Like there's always new innovations and like like emerging like techniques on how to do this. But for example, my classes will have multiple instructional modes. So I'll mix lectures with formative eye clickers or end of class mini quizzes or just think, pair, share, circle chats, journal clubs, and even in the types of assessments that would really cater to diverse learning styles. So if there would be those traditional exams, but perhaps there will be online quizzes that allow students to engage with the material in their own time,
Yep.
as well as like written reports for the smaller classes and the critiques and oral presentations for those third and fourth year classes. But apart from that, apart from strategy and assessment, I feel like universal design emphasizes access. So it might not be mandated within the university, but I record all my class lectures. I feel fortunate that I've been assigned to classrooms with high
So you can
flex,
do that. Yeah.
so I
Yeah.
can do that. And then apart from recording it, it's live streamed. So students who are working full time, for example, or might have missed public transit or are not feeling well to come on campus, they can join the class online, join the iClicker polls because they're now like within the cloud services as long as they have the
Yep.
subscription.
Yeah.
But of course, there's that balance. Like, how do I still try to maintain attendance? So there are some perks, of course, with attending in person. So a lot of our discussions or most of our discussions will be in person because trying to juggle the chat live stream while I'm
Yes.
delivering an
Yes.
in-person lecture
Yeah. Very
cannot be
challenging.
done.
Yeah.
So a lot of the more interactive activities like that would be the perk of attending in person. But I acknowledge that I need to meet students where they are at, and I believe access is one of the most important things to consider when designing courses, especially in the 21st century when circumstances have changed.
Circumstances have changed and our students have changed.
Oh,
So
bingo.
the majority of our students are the so-called non-traditional student, right? Many students don't live on campus or close to campus. They
Yes.
commute, increasingly commute now because of the cost of living someplace else and the cost of an education. Often they're caring for family members. You note in your dossier recognizing students often work, and the data on working is that, it might be up to 27, 32 hours a week, right?
Oh, yeah,
Which
that's full time
that's
or
full
reaching full
time,
time.
absolutely, right? And they're trying to balance that with schooling. So it's, your approach allows students living in a variety of circumstances to access knowledge.
Yeah.
Right. Your interest in engaging students in scientific inquiry is it's not just for students here. You also reach down and you participate in the SHAD program for
Yes, I
grade 10
do.
and 11 students. And that is a month-long STEM slash entrepreneurship challenge. So talk a little bit about Chad and your engagement with that. Like, what have you got the students doing, again, to bring them into that scientific inquiry network?
That's fantastic. And indeed, this is part of my philosophy on really engaging not just university students, but students in general or learners in general.
Engaging the future scientists.
Exactly.
Yes.
And SHAD is that perfect opportunity because the high school students are here. And I was first involved with it in 2022. It was Sunny Wang from,
Yes, yes,
or yeah, from
yes,
math who was
yes.
spearheading it. And what my contributions for SHAD has been this mini seminar on plant immunology, aka how do plants successfully defend themselves against pests and pathogens in a changing
I was
environment.
going to say, in a climate impacted world,
Yes.
this question is a clear and present one.
And
Yeah,
because like that is
yeah,
my passion for my research program, that was the perfect
right.
opportunity to engage high school students about the plant immune system. I mean, not a lot of people even know that plants have an immune system as well. We tend to associate immune systems just with animals or humans, but plants have their own sophisticated immune system that actually have parallels with what we have as a human being. So for that mini seminar, I use the same pedagogical tools as a university class so that they can actually see how, like what
This is
does
what it's like.
university
This is what
learning
it's
and
like.
teaching,
And this
how
is
it
how
is.
awesome it is.
But I frame it through the scientific method. So
Yeah.
I share a study that we did in our lab, and then I organize it from the research question, those initial observations, and then the generations of hypothesis, how we tested each of those hypotheses, and then I present all hypotheses and where we got things wrong until we arrived at the correct hypothesis per se. And
Showing them the journey.
yes, showing them the journey that science is not just a static set of facts like canon that just, like would
We have to
would arrive
memorize.
as a
Yeah.
eureka moment, but that science is actually messy. There's a lot of experimental failures or wrong hypotheses that are disproven, and that science is evolving, and that science is debatable. So I think by showing them that journey, hopefully that would allow them to see that science is for them. It's not something distant and remote, like in locked up in an ivory tower, that science is accessible and science can be done by anyone who's interested.
And just to carry that further, you bring a lot of students into your lab. Everyone from first year undergrads right through to your PhD and postdoc students,
Yes.
right? How do you do that, right? You're bringing them into a lab environment with learners at different levels, right? So what does that look like in your lab?
So definitely, because as you know, research programs, like the engine of research programs at Laurier and all universities are really the students and the postdocs that do the day-to-day experimentation and writing, like all of these different facets. So I do kind of a bespoke, customized mentoring plan at each stage. Of course, like for undergraduate students, it's really about building that confidence and trying to help them with foundational skills in the lab. For graduate students and postdocs, perhaps it would be more for independence, gaining that independence, that ownership of their project, exploration, plus more on focused, specific career planning and mentoring. But apart from the career stage per se, mentoring is always unique per individual. It's not like a research protocol that once you've optimized it,
You just
that's
template it
it.
onto
Yeah, you just
everybody.
template it for. So like
Yeah.
there's always, again, there's like an evolving conversation for each trainee, because like they have their own unique needs, their own unique core values and interests, and their own unique career goals. But what is universal is that as a lab, I ensure that like every voice matters, that we celebrate wins, however small, that we troubleshoot failures or problems collectively and in a safe manner. So I think being able to do science in an inclusive and welcoming environment actually harnesses those creative juices for students to push forward with their projects. So for example, even though the mentoring plan will be unique, I'll have one-on-one meetings with each lab member every week. So for 30 minutes or maybe an hour, if they need an hour, they can talk about, like what worked in the lab, what did not work, or just what their progress is for the week, or even just like how they are feeling that day. And really, my first question with each trainee is, how are you, instead of how's the project going, even though that might be the main agenda. I think setting the tone that well-being and scientific rigor can go together and should go together is important for my mentoring philosophy.
So you're an early career teaching excellence winner.
Oh, thank you.
What's next? Right? Like, so what are the horizons in terms of, again, building, the scientists of the future, ensuring that you've got students that are turned on to scientific inquiry? recognize that science is messy but incredibly exciting, right?
Yes. Yeah.
So what's next?
I mean, definitely I mean, like, I'm excited at both the known and the unknown. I mean, especially in the age of artificial intelligence, like this disruptive technology. So, for example, let's talk about AI. One of my big dream goals is to hopefully work with like institutional collaborators within Laurier, or even partners in the publishing industry on how we can implement Gen AI personalized tutors or adaptive learning or even
Yep,
adaptive testing
yep.
that would cater to the unique permutation of needs for each learner. So, one thing I can envision with adaptive assessments, for example, wherein each student's questions, like each student receives a unique set of questions that might get harder or get easier depending on how they answer uh, previous questions. Of course, like those questions will be all designed and vetted by the instructor, and then that allows, there's no perfect score per se that is a standard perfect score, but there's something that each student can work towards,
Have you strengthened in these
yes,
areas?
yeah,
Right, yes.
exactly. And I
Oh,
mean,
how interesting.
we have a unique opportunity here at Laurier to really be at the forefront of AI, because it's a level playing field
Right
across
now.
all
Yes, that's
institutions
right.
globally. And I think it's important for us to embrace it while making sure that the guardrails, the safeguards are there, that we maintain academic integrity, which is an important tenet of teaching and scholarship. But I think being able to, like, I know like it's such an overused word, to leverage AI for learning, I think the opportunity is there, and it's quite exciting. And because AI is a deluge of information, but like we were talking about, knowledge does not retire, and knowledge is not just information. Like there's that um, quote that knowledge is information times power. It's how we critically evaluate information, how we generate new information, how we interpret, what is accurate and not. It's really becoming more and more important that we train students not just what to know, but how to think. And how to think can be
Absolutely.
inculcated with integrating and incorporating research further in classroom learning. So I know in a few universities in the States, like they have core undergraduate research experiences
Yes,
or
yes,
classroom-based
yes, yes,
undergraduate
yes.
research experiences, wherein instead of that one-on-one thesis project, perhaps we can incorporate research at scale using big data findings and big data sets in genomics and transcriptomics that is at the forefront of biology. And by having this project-based learning approach, students get a more holistic and integrative understanding. Like they would need to ask questions like, oh, I need foundational concepts, and then that will be discussed in its relevance to that particular project or research problem for that semester.
Well, it sure sounds like you've got lots of things on your
Yes.
docket there, and you really make me want to take your biology class.
Oh, such high pressure for me.
Thank you so much, Danve, for joining me here today.
Well, thank you very much for the
It's been a pleasure.
opportunity. It's been my great pleasure. And thank you for recognizing my efforts as an educator and teacher here at Laurier. It really means a lot.
Please note it's your students and your colleagues who have brought this to the fore. So thank you. My thanks to Christian Danve Castroverde for joining me today, and I hope you will join me for more conversations that celebrate exceptional teaching practices, explore diverse teaching philosophies, and discuss the future of higher education teaching and learning.